Hello guys, welcome to my YouTube channel. Today we'll discuss another question from GATE 2024. In this question we are asked about an initial value problem y dash equals to e power minus y square plus 1 with initial condition y0 equals to 0. And examiner was asking whether this IVP has unique solution in R, and this solution, if it is unique or not, and every solution of IVP is bounded in maximal interval of existence or not, right? Let us proceed to our notepad and let's see what we can do with this question. Okay, so we are given with IVP y dash equals e power minus y square plus 1, right? With the initial condition y0 equals to 0. For statement 1 at least, what we can do, we can think of this differential equation as y dash equal to f of y basically, where f of y equals to e power minus y square plus 1 is a function given to us. So if he's asking about uniqueness and existence, you can think of Picard's uniqueness and existence theorem, and you can basically try to see whether this function is ellipsis or not with respect to y. For that, what we can do, we can check for its partial derivative. Let's see, or in this case it will be derivative only. Let's see if we differentiate this function f with respect to y, what we'll obtain, we'll get e power minus y square minus of 2y, right? And can you see this function is bounded in R? Because as y tends to infinity or y tends to minus infinity, this quantity will always go to 0. So this function is basically bounded. This implies that e power minus y square minus 2y is tending to 0 only. This will give me the condition that its partial derivative is bounded for all y belongs to R, right? That means this function of y is having partial derivative which is bounded in R. That thing will imply that f of y is a ellipsis function of y, right? By uniqueness and existence theorem, now we can say that y dash equals to e power minus y square plus 1 has unique solution in R, right? One additional condition is that this function fy is basically self is also bounded. This function itself is also bounded, and whenever we have scenario like y dash equal to fx fy and f is bounded function of y, then maximal interval of existence will be R. So in this case, what we have claimed that maximal interval of existence is R. You must be thinking why I'm claiming that maximal interval of existence is R. You'll see in the second part basically. And the second part is, we were asked about whether every solution of this differential equation is bounded in R or not, basically in maximal interval or not. So we were given with y dash equals to e power minus y square plus 1, right? Can you observe about this function, whether this function is greater than or equals to some fixed quantity or not? Definitely this e power minus y square will always be greater than or equals to 0. It cannot be 0 anyway, right? So what I can say, that this quantity will always be greater than 1. That means y dash is basically greater than 1 for all x belongs to R, because our maximal interval of existence is R, right? What we can do, we can integrate both sides, because integrating because taking integration will not affect the inequality. This is a monotonic function, right? If we try to integrate, and we're taking basically limits, okay, we are taking limits from 0 to x basically, because we are provided with initial condition at 0 only. So let's integrate. This will give me this inequality, and this further reduces to yx minus y of 0 greater than or equals to that x only, right? Because y of 0 is given 0 to us initially, this means yx is greater than x. That simply means as limit extends to infinity, as limit extends to infinity, or we can say as x tends to infinity, as x tends to infinity, our function will definitely tends to infinity, because if left hand side is tending to infinity, the smaller quantity is tending to infinity, then larger will definitely. That means, because this was for every solution, right? This was for every solution. That means every solution of this differential equation is unbounded, which was contrary to what we are given with, that every solution is bounded. So this statement will be true, that first statement that it has unique solution, and second statement will be false, right? So the correct option is option number B. The first is true and second false. I hope you like the video. Please subscribe to my channel. I'm planning for uploading such more such content. Thank you for watching.